We're going to review some geometry here, how to identify a trig ratio and the signs. First, it's important to know when you look at an angle, which we could call theta, the side across from the angle is always called the opposite. So if I was talking about this angle, this one down here would be the opposite. So whichever is across from your angle is your opposite. Hypotenuse is always across from the 90-degree angle, the longest side of a right triangle, and that leaves the adjacent to be the other side. So basically, for any angle, the hypotenuse and the adjacent make the angle, and the one across from it is the opposite. Make sure you know that. Because you do need these trig ratios, sine, cosine, tangent. It looks like sin, cos, tan, but I do prefer you say sine of an angle, cosine of an angle, and tangent of an angle. So you should remember, I'll just put it here as a little index card for you. You should already know sohcahtoa. Basically, sohcahtoa, you have to spell it to be able to use it. So, S-O-H, ca, C-A-H, toa, T-O-A. So the sine is the opposite over the hypotenuse. I wrote it down here. Cosine is adjacent over hypotenuse. I wrote that here. And tangent is opposite over adjacent. But this does make me need to introduce the other three trig ratios, just so we know that there are actually 6. Whatever sine is opposite over hypotenuse, cosecant is the reciprocal. So sine and cosecant of an angle are reciprocals. The reciprocal of cosine we're going to call secant. This is the way you write it short, S-E-C, but you do say secant of an angle, and that would be the reciprocal. So if cosine is adjacent over hypotenuse, secant is secant is hypotenuse over adjacent. And the reciprocal of tangent is cotangent of an angle. So cotangent, you would shorthand write COT of a theta. If tangent is opposite over adjacent, cotangent is adjacent over opposite. All right, so here's some delta math I'm going to ask you to do in my class. If you have this triangle, LUV, you have to find an edge, and LV, and the tangent of angle L. So we'll set this up. It says that U is 90, so I'll make this one U, and we have these two others, L and V. So if I already marked angle U as 90, L to U is 30. So this is an edge, this is not an angle. Angles have that degree symbol. So LU is an edge, 30. UV does not have a degree symbol, so that's an edge, a leg, and that's 40. And that reminds me of the 3, 4, 5 triangle, a special Pythagorean triple, because 3 squared plus 4 squared is 5 squared. So as long as you have multiples of 3, 4, 5, like the 30, 40, 50, you basically can quickly find the third side if you know any of your Pythagorean triples. Going back to the trig, you're going to need to now say what LV is. So we just found LV, and we said it was 50, and we did that because we knew of a Pythagorean triple, the 3, 4, 5. Otherwise, you can use your Pythagorean theorem and say 30 squared plus 40 squared equals C squared, and solve for C. The tangent of L. So now this one, you would say tangent of angle L. So if you look at L, L is actually up here. So tangent, toa, opposite over adjacent. So opposite of L over adjacent. So what's opposite L? If you go across, you'll see it's the 40. And the adjacent could either be of these, so you have to look and see. The one opposite the 90 is the hypotenuse. So the 30 is the adjacent. And then, of course, you can reduce that. So the answer to this problem is 4/3, unless you're supposed to round to the nearest tenth. You also need to know what quadrant that angle's signs are. So what I'm going to do is I'm going to get rid of this part of the problem. So if you need to take a picture, go ahead. And what I'm going to do now is I'm going to say, what are the signs? So for all intents and purposes, if you have an angle, opposite is part of the sign statement, and that's an up and down movement. So I'm going to say from moving forward that sine is y. Adjacent, you're moving left or right, so we're going to say that's cosine. And tangent is opposite over adjacent, so we're going to say tangent is y over x. So you are actually going to have to try to memorize that at some point. And so if we wanted to talk quadrants, in quadrant 1, cosine and sine are both positive, because cosine is x and sine is y. In quadrant 2, cosine is negative, but sine is positive. In quadrant 3, because you're going left, that means the x is negative, and because you're going down, that means the y is negative. And because x is cosine, you can say that cosine is negative and y is negative. And in quadrant 4, go ahead, cosine is positive and sine is negative. So you're supposed to be trying to figure that out with any type of trig function. So for instance, if I said tangent, when is tangent? I'll write that a little neater. When is the tangent of an angle negative? That says less than 0. So since tangent is y over x, a positive over positive stays positive, and a negative over negative turns positive. So the only time tangent of an angle is negative is if you have a positive over a negative or a negative over positive, since tangent is y over x. So you could say that theta was an element of quadrant 2 or 4. That's a nice way to put it into some set notation. We'll do one more. If you wanted to do when cotangent was positive, now we're talking about one of the last 3 trig functions. Whatever sign you use for sine is the same as cosecant. Since they're reciprocals, the signs wouldn't change. Cosine's got the same sign as secant, and tangent has the same sign as cotangent. So if I know that sine is negative, let's see, when is sine negative? Sine is y. So sine is negative when sine is y. So sine is negative in quadrant 3 and 4. So cosecant would be negative in 3 and 4. If I wanted to do when is cosine positive, now cosine is x, so cosine is positive in quadrant 1 and 4, which would mean secant is positive in 1 and 4, because again, these are reciprocals, they're not opposites, they're just reciprocals where you flip them. And so this question says when is cotangent positive? So cotangent is going to be positive when tangent is positive. And the only way to get tangent to be positive is when y over x is positive. So this is our most common thought, is in quadrant 1, they're both positive. So cotangent, like tangent, would be positive. So you could say quadrant 1, and the only other time you get a positive is if you put not a positive over a negative, but a negative over negative. And so you would say quadrant 3. So we're going to have you give that a try on some delta math now.